Okay, so angle relationships. We did have homework due today. So if you have not turned something in that front basket or back basket yet, make sure you're doing that right now. Let's click through here just so you can see this. So here's the outline, one more time what we're talking about. These are the words we discussed yesterday. Let me zoom in one more time. Talk about adjacent angles, perpendicular, linear, pair, and vertical. I want to do one quick review of those, especially perpendicular. We have new words. Then our goal is to get to the two new vocabularies, complementary angles and supplementary. We're going to spend the most time on those today and do a bunch of examples of them, especially like algebra-based problems, stuff that you had in the homework yesterday, those last few. And again, homework that you turn in, I'll grade it and I'll hand it back to you probably next week, probably hopefully Monday, and then you can make corrections and fixes and kind of get it figured out. All right, but there you go. But homework that was due today was this. It's due. Get done. Get wrapped up. Okay, I'll give you a little bit of time to write that down. Let me take attendance real quick here. Okay, so let's get started here. Alright, is everyone good with the outline? Everyone's got it? Perfect. Let's jump right in. Adjacent angles, one more time. They're angles that lie in the same plane. I don't know if I stated this yesterday. Why that first thing, why you have to have two angles in the same plane? You could have an angle, let me actually give it a drawing here. I could give you an angle like this, where they have the same vertex, they have the same wall in the middle, and so these are adjacent. They're side by side. They don't necessarily have to be equal. They can be different sizes, like this picture, but that's adjacent, right? There is this weird option where you could draw an angle so that it's going two different directions. What I mean by that is that I could have a plane like on a piece of paper, right? That's a piece of paper, it's a plane. And I could have an angle drawn on it like this. Where this is the vertex, this is the angle, we'll call this angle number 3. And then there could be this angle that is going off of the paper, where it's going like up in the air. And it's going up like, so if your angle's flat on a piece of paper like this, the next angle will be going up in the air from here. Like, I'm gonna put a dashed line that it's going up. It's going up in the air. So they're not on the same flat surface. They still share a wall. They share this wall right here. They share the same vertex. So it looks like by definition that they're adjacent to each other. But if it's going up in the air, that's off the plane. It doesn't count. So when we draw pictures, they have to be on the same flat surface. I don't want a three-dimensional picture where one of these angles is like folded upwards. Okay, I want them flat. I know it's really hard to draw three-dimensional stuff. I can't do that. All right. But again, there can't be any interior points. So what that basically says, there's no overlap. You can't have overlapping angles. Questions on what adjacent means. Now, in the homework yesterday, they used the word bisector for number 9 and 10, and those later ones. Bisecting means that if this is a bisector, so if this is a bisector, that means that's a big fancy word for saying that the two angles are equal to each other. So they'll do this. They'll draw a little bubble in each. Those two angles are equal. They're congruent now. So whatever they are, you can set them equal. So if they happen to give you numbers or variables or whatever they are, maybe they told you this is a 4x minus 6, and this is a 2x plus 10. Now that type of thing, we can solve that. Because if the two angles are equal, just set those two things equal to each other and solve. Sometimes they didn't do that. Sometimes in the book on number 9, they only gave you one of them. They gave you the 2x plus 10. And they said that this overall angle is an 8x plus 18. Okay, so if that's the case, then what you have to make sure of is that you add two of these together. Two of these, because they're both the same angle. It's still a bisector, so I could go to 2x plus 10. So now you can add the two together to make the big one. So 2x plus 10 plus 2x plus 10 equals the 8x plus 18. You can do something like that. Or you could add two smalls to make a big. But that's really all that homework was doing for 9, 10, and the later ones, like 37 through 39, that type of stuff. They're having you try to solve for variables, but you had to read the instructions. If you didn't read the instructions, you would never know that certain angles were equal. You couldn't transfer things around the picture. We'll see another example later with the hair, but that's adjacent. Questions on the first word. When angles are next to each other, you can actually add them like that. Perfect. Okay. Perpendicular. This is the one where we have new stipulations. Perpendicular is anytime you have a line, ray, or segment, it has to be some type of line, where they're forming a right angle. So this is the picture I gave you yesterday. What is the symbol that we use for right angles?
Square.
The little like pink square, right? It's this thing right there, that little pink box. If you have the pink box, that guarantees you have a right angle. Now we have the notation that the book uses. It has that little upside down T symbol, this thing. That little upside down T means you have things that are perpendicular to each other. So AD, this line, is perpendicular to the line C to D, so it means you have 90. Now the 4 stipulations you need to write down. These are the brand new things. I kind of waited till today. Number 1, the perpendicular lines, when they intersect, when they cross, they form not just one right angle, because you see there is one box in that picture, right? But they form 4. There's actually 4 right angles in there. So if you wanted to, on this picture, you could actually fill in all of these boxes. You could fill them all in. But if you have one right angle, there's 4 of them around it. That's the first stipulation. Now the reason why I waited today to show you that is because the only way you would know that that would actually work is if you knew what vertical was. Because if I have the 90 up top, you can transfer the 90 straight down. And now you can start doing all the work with the verticals. So you can start adding these two to make 180 because it is making a straight line. And you can subtract 90 and get 90 left over. So there is 4 right angles there. That's the first stipulation. Most people can kind of figure that out, but if it's not written in there, if you see one right angle, like that, you can actually fill in the one next to it. As long as it was a straight line, A to D was straight. Perpendicular lines, when they intersect, they form congruent angles, and those angles are adjacent to each other. So no longer are they just right, but they're also called quote-unquote congruent. They're equal in size, shape, and measurement. So now, why that would be important? Because maybe the book will do something like this. Maybe they'll do something like that. Okay, well, if you know that these are both supposed to be right, you could actually set these equal to each other. If it's perpendicular, that's what this thing is saying. So now you could go 90 is equal to the 2x plus 5. And you could solve it from there. Because you know from the second stipulation that the angles next to each other have to be equal to each other. They have to be equal, so you can set them. That's if it's perpendicular. That's second stipulation. Third stipulation. The segments and rays can be perpendicular to lines and other segments and rays. So it is that it's restating that first thing, that you can have segments and rays also perpendicular to other objects and pictures. So I think I showed you yesterday this picture of boxes and triangles crossing each other, something like that. That you can actually have right angles on the outsides of pictures because the rays and the segments on the outsides can also be perpendicular. And this is actually saying something a little more important as well. This is something you're going to get later. That you can actually, it's called a transitive property. I know that seems like a weird word. You can transfer properties from one picture to another as long as they share things in common. So if you have a bunch of lines and they're all perpendicular, then you can start transferring the properties down to the other pictures. So it could be something like this, where you have more. So if you have lines like this, and one of these is perpendicular, and you know that all these lines are parallel, you can start transferring the perpendicular all the way down. You can have more than just one line being perpendicular to the same thing. That's called a transitive property. That's what this is hinting at, it just didn't give you the name yet. We're going to see that later when we start talking about the parallel again. That's like that. the section is that. Is that chapter, I think it's chapter 2 or 3. We start talking about parallel a lot. We'll get back to that definition again. It's chapter 2. All right, next, the last stipulation, right angle symbols in the figure indicate that it's perpendicular, so that's that little box. So, because again, perpendicular and right angles go hand in hand. They're basically the same word to me. All right, questions, comments about the first one? Or I guess the 4 stipulations here. All right, writing that down, that'd be good. Let me check the camera here. Okay, linear pair, new word. Did anyone need that? Sorry, did anyone need that last slide? Perfect. All right, linear pair. This is the one we did yesterday, right? Linear pairs, anytime you have angles that are adjacent to each other, and the walls and the outsides make a straight line, they make opposite rays. So here's your picture. The outside walls form a opposite ray, or a straight line. So if you know that two angles are coming together to form that straight line, you can add them to make 180. That's called a linear pair. But it has to be a pair of angles, and they have to be side by side touching, and they have to make a straight line on the outside. So be careful of that. The symbol we used yesterday, the book will sometimes do this. We'll draw like a little bubble on that. That signifies that it is 180 degrees. It's the whole protractor. It's not trying to say that the two angles are equal to each other. This kind of looks like that. They're trying to put the bubble in there, but they're not. They're trying to show that it's 180. Now, why that's important? Your homework had some of that. Number 9, 10, 35, 37, 39, those. Where they would give you these things, 3x plus 5, 2x plus 10, and they would ask you to solve for x, and oops, 2x plus 10. What am I doing? 2x plus 10. They ask you to plug them in and solve, for a certain angle. Maybe they said find angle number 1. Okay, well, knowing by looking at this picture, you can add the two angles together to make 180. That is a straight line, so that all of that adds to make 180. So you can add them up. And this is just two angles added together. But again, that's called a linear pair. You're allowed to do this. The definition of linear pair is just that they're side by side and then make a straight line. So you're making all 180. The fact that you can add them, that's called angle addition. You can do that when it's obvious from the picture. This is the part I think some people get stuck on. They didn't know you can do that. It doesn't always have to be 180 for other pictures. This picture has to. It's a straight line. You could have more than two angles, but that would be different. That's the other words coming up later. Okay, we're good with the linear pair. All right, now. Vertical. This one, I think we ended with this one yesterday, correct? Like this is our last word. Vertical angles are two non-adjacent angles, so they're angles that are not next to each other. They can be across the picture, but they're formed by the intersection of straight lines, two lines crossing like this. So we do have two lines crossing, straight lines. Vertical angles are the ones that cross from each other. It's what I think I call it the funnel system. It's literally making a funnel. That if you had a liquid up here, it could go through the funnel and come out down here. These two angles, 1 and 2, are vertical. They're also equal to each other. That's one of our first properties you need to know. Vertical angles are equal. So if somebody give me a random angle, any number you want.
37.
37, okay? Let's say this is 37. The picture looks terrible, but it's 37 degrees. If that's 37, you can transfer that to the other side. That's what vertical means you can do. And if I knew those were 37, I could find the angles next to it. These angles here would have to be a 43 or something like that. 43 degrees, 143. Then you can transfer that over. Now why I know that? Because any two, these form linear pairs, they have to add up to be 180. That's how I knew how to do it. Okay, are we comfortable with vertical? They can transfer it across. But that only works if they're straight. If there's any bend in the road, it doesn't work anymore. It fails the picture. That's really tough for people to see. You start seeing a picture like this. So here's a straight line. you have something coming off of it this way, but then this one goes this way. You don't have vertical angles anymore on this picture. There's not. This angle here is not vertical to that one. You can see they're different sizes. They're not transferring straight across. There's a bend in the road. It has to be straight lines crossing. That is the hardest thing for people to wrap their head around. This does not work. You cannot do that picture. Okay, other pictures. This is what the book will show. I pulled this out of the book because I didn't show it to you yesterday. They're going to use like notation bubbles to show that certain angles are equal. You've been seeing me do it on the board, but this is how the book shows it. So you can see that. They put a single bubble, that means that angle's the same. They use a double line, that means it's equal to the double line over here. You can see that. That's how the book shows that you have vertical sometimes. So certain angles match because of those markings, those red little bubble symbols. Questions on vertical? Okay, new word today, brand new word. Complementary. This is the stuff you probably should be adding to the notes now, other than the perpendicular stuff. Okay, it's two angles that have the sum of 90 degrees, that's complementary. Complementary angles, sum to be 90 degrees. They're going to add to make a right angle. But it's two of them. It's not just one angle being 90, it's two of them put together to make a 90. So the example I give, because I know a lot of you are storing the words, this is the picture I always show people. Do you see that there's two angles put together to make 90? That's complementary. You would not believe how many people will look at this picture. I'll have something like this in the book. Let's call this A, B, and C. It always makes me laugh when somebody does this. They're like, oh, that's a complementary angle. That's a right angle. Get the words right. That's a 90-degree angle. It's not complementary. Complementary is when you add two together. So whatever the two numbers are, I don't even care what they are. It could be 45 and 45. It could be 60 and 30. I don't care. As long as the two numbers somehow come together to make 90. They don't have to be the same number. They could be different, as long as they're adding. Now, the part that really gets people, on this picture, did they say they had to be adjacent to each other? Was that in the definition? No. You could have pictures or angles that are across the picture that aren't even attached to each other. But you could add the numbers together, the digits, and still get 90. They would still be called complementary. That's the difference. I know that seems really weird. They're not even attached, but you could add the numbers. 65 plus 25 still makes 90. They're still called complementary. We're adding the numbers together. That's what you should be thinking. Okay, questions? Okay, I think it's pretty straightforward. It's just that it's one of those things you just need to see it for the first time. They could give you a picture like this. I know this is what the book will eventually do. They're going to give you a picture like this in your book. You'll see all the markings of angle 1, 2. The homework will eventually say, hey, angle number 1, the measure of it, is supposed to be a 4x plus 10. And angle number 2, the measure of angle 2, is supposed to be a 6x minus 7. Solve. Okay, so then you got to add them together, set equal to 90 and go. Because you know by the picture when you add 1 and 2 together that does make 90. So you have to add, set equal to 90. So just be careful with that. We'll practice that more probably. Today is just about getting these definitions done. Okay, we're good on complementary. Supplementary, last word of the day. Last word. Supplementary. Two angles that sum together to make 180. Two angles that are going to sum to be 180. Now when you see the picture, there's going to be another vocabulary that's going to come in your head about when you see it, because they go kind of hand in hand. Supplementary angles are angles that add to make 180. Here's the picture I always show. Okay, there it is. What does that look like to you? Say it again? They're adjacent angles. That's number 1. Boom, nailed it. Right? They're adjacent angles. They're side by side. What else? What else? What other vocabulary did we talk about today that kind of look like that same picture. It was one of the words we had earlier. Which one gives me that style picture? Say it again. Linear pair, right? The linear pair gives me that picture. Because duh, linear pairs make a straight line, so they have to add up to be 180. Now, the big thing you said, these look adjacent. The definition doesn't say they have to be. So I could have two angles that are not even attached to each other, but when I put them together, like add the digits, it still makes 180. They're still called supplementary. So you can add up angles that are kind of across the picture. The numbers, anyway, to make supplementary. Now, the types of problems the book will have you do, again, they give you numbers or variables in here. You can add them together to make 180. But you have to know that it is a straight line. Sometimes they'll put the little like notation down. So they'll say like this line is straight. That's a straight line. Because sometimes that's a subtle jab. They say, given the following picture, and on the following picture, AB, line AB intersects ray BC. Ray B to C. Maybe that's what they say. That's a really subtle jab to say that, hey, you have a straight line, you have a linear pair, you have a supplementary angle there, where you can add two together. Because the reason why they're doing a subtle jab is that they're saying this bottom line was straight. It's a line, so you know it was making 180. That's really subtle that they could do that. Questions, comments about any of the vocab words today? Perfect. Okay. Homework. Oop, there's another one. Same picture. All right. Homework today. We better get to that. Okay. If you haven't turned it in, it's due today. Now, wherever you want it. If you have questions, this is a great time. I have about 10 minutes or so. If you have questions on the homework, you want to go grab it. You want to ask a question, see how to do it. You want to make a fix to it. If you want to do that right now, you want to take a look at it one more time. Do that. On Monday, we're going to talk about the linear pairs and the supplementary and complementary one more time. We're still going to get homework next week, even though we have a test at some point. I'm expecting probably Thursday. We're going to start probably the review process, so be ready to go. Monday, you probably need a textbook. I'm going to check to see if the online versions work here in a second, so I can actually handle those out. Yeah, about to check that. Okay, good. So I'm just going to check. So if you have a Chromebook out, you might want to pull that out here. If you have an online version, you can log in. I can tell you who has one. This would be a good time to check. So I'm saving time today to do this. All right, let me turn off the camera because I don't need the whole internet knowing the passcode.